Hello and welcome again. We are quite appreciate you coming to class. Now, previously we've looked at this, we've looked at this. In all, we'll be looking at application of the laws of indices. Now, we're going straight today to this. Now, what we decided to do is break this because it can be lengthy. We're trying to be cautious about making the videos long, so we're going to take them in three parts. The first, we're going to move an exponential equation, which this is an exponential equation. We're going to solve it. We're going to take it from here to a quadratic equation, and then we're going to solve it. We're going to get the roots of the quadratic equation, and then from the root we'll now find the values. So values of, for example, now what we have here is actually x, the values of x. So we'll take the first step. Now in this case, that means we're moving 4 steps. So let's see, the exponential equation, we're going to move it to quadratic equation, and let's see how it happens. Now let's come here. This is 5. Solution, I'm going to 5 to x plus 1 minus 26, 5 raised to the power of x plus 5 is equal to 0. Now, the first thing, don't forget, make this place look like here. Now, what we'll do is this. There's a rule, most times it's arranged to be the first in the laws of indices. It is called the multiplicative rule or the product law, and it states that a raised to the power m times a raised to the power n. The rule states that the product, when a product of two numbers have the same base, what you should do is to use one base and add the two exponents. So we're using one base, we're going to add the two exponents. So if we had this 3 times a raised to the power 2, it's going to be a raised to the power 3 plus 2, not times plus. If you spread this out and spread this out, you'll still get a raised to the power 5. Now what we'll be doing here is to do the reverse here. Reverse it. Move from here to this place, or move from here back to this place. So that will be what will happen here. Now this is the same thing as saying 5 raised to the power of 2x times 5 raised to the power of 1. 5 raised to the power of 1, because we eventually use the two powers. The two of them have the same base. So we decided to use 1 to make it this way. So minus 26, 5 raised to the power x plus 5 is equal to 0. So how do we bring the two of them to look alike? Now, having known this is the same thing. 5 raised to the power of 2x is the same thing as 5 raised to the power. It still means 5 raised to x 2. It's the same, like you say 5 raised to the power of 2 times 3. It's the same thing as saying 5 raised to the power of 3 times 2. So 2 times 3 is 6, and also 3 times 2 is 6. So you just switch it. Mark it. If you know the rules, you can put this in front, put this behind, or put this behind. So you can switch it. So it's the same thing we're going to do here. So we're going to move here. This is the same as saying 5 raised to the power of x times 2. In other words, just put a bracket here. Times 5 raised to the power of 1 minus 26, 5x plus 5 is equal to 0. Now we've not done anything on this part. Nothing yet, but we've been working on this place. Now can you notice something? Have you noticed that here now looks like here? So what we'll do is that we'll use an alphabet. Just use any alphabet. Which we use? Let's use alphabet F. Anyone, you could use anyone. Or let's use, do we want H? Let's use H. So using h to represent 5 raised to the power x, so we'll have it as h raised to the power, so wherever you see 5 raised to the power x, you put h there. H raised to the power or 2, so wherever you see 5 raised to the power, you put h raised to the power 2 times 5. Now 5 raised to the power 1 is what? 5. Any number raised to the power of 1 is the same number. Don't confuse it with 5 raised to the power 1 is the same as 5. But don't confuse it with 5 raised to the power 0. 5 raised to the power 0 is equal to 1. Any number raised to the power 0 is 1. But this 5 raised to the power 1 is 1. So don't confuse them. So this is h minus 26. 5. Oh no, this is gone already. So representing this with h plus 5 is equal to 0. 5 times h is what? 5h plus, minus 26h plus 5 equals to 0. Let's look at it properly. It looks like a quadratic equation. This is what we're going to start today. So we've got the quadratic equation. I will stop here. For the length of the video, it's likely to get to 20 or more minutes if we try to go through it. So I want to take it gradually so that you would understand. Now, I want you to do yourself this favor. Go to the previous video, learn how we solve this, and then watch out for the next video to see how we transit from here. We are now here. How we transit from here to finding the roots of the question. Thank you.